This should have been included, but it should have said 0 to 5. So we're going to just go ahead and do it since it wasn't really, you couldn't have done it really all the way without. So look at the top. We're finding absolute extrema. Okay, this is homework 1. So if I want to find absolute extrema, I'm doing a first derivative test. What do I do first? Take the derivative. Okay, what rule do I need? Product and chain. So my u is going to be 2x. My v is going to be x minus 4. What's u prime then? Oh, I did write that wrong. E to the 2x. Thank you. So then the derivative of that would be e to the 2x times 2. That's where your chain rule comes in. Because it's not just an e to the x, it's e to the 2x. So my core is a 2x, I have an extra times 2. Okay, then for my x minus 4, what's the derivative of that? 1. Okay, so f prime of x equals, we're doing one diagonal plus the other. So let's say I do this one first. E to the 2x times 1, I'm not going to put it, plus. Other diagonal, e to the 2x times 2. And then times x minus 4. Now, when you're looking at that, remember, if I'm setting it equal to 0, I'm looking for a GCF. So I can remove the e to the 2x. What is left over, though, from this first term? Because if I pull that out, I can't just leave nothing there. A 1 plus. Then from the second term, I'm taking out the e to the 2x, but what is still left over? 2 and an x minus 4. Now, when I combine like terms in there, I'm going to distribute first, then combine. So if I have a 2x minus 4, 2 times x is 2x, but what's 2 times negative 4? Minus 8. And then if I have a 1 in front of that, combine the 8 and the 1, what do we get? Good. So you have e to the 2x. And then 2x minus 7. Okay, what are the x's called that make that 0? Critical numbers. Okay, and then 7 over 2, that's right. Okay, is there another one, though, from the e? No, because even though e asymptotes towards 0, remember, it never actually crosses 0. Okay, so I have only one critical number. 7 halves. Now, do I have to make a line test if I want absolute extrema?
No.
No. So we're doing a candidates chart. So x, f of x, what goes in the chart? What two types of numbers? Okay, the endpoints, which are 0 and 5, which you didn't have when, and your critical number, which is, what is that as a decimal? 3.5. Okay, so remember, in your candidates chart, you're putting endpoints and critical numbers. Now, where are we plugging into again? The original. Back to this guy right here. So, plug in 0 to that first. So, if I have e to the 2 times 0, that's e to the 0, and then 0 minus 4. Well, e to the 0 is 1, 0 minus 4 is negative 4, multiply 1 and negative 4, what do you get? Negative 4. That's my first y value. Okay, 3.5, we're plugging it in up here. E to the 2 times 3.5 is e to the 7. And then 3.5 minus 4, what would I get there? Negative 0.5. So I'm going to write that as negative e to the 7 over 2. Are we okay with that? Okay, 0.5 is really a half, so I'm putting a divide by 2 on it. Okay, last one. We have e to the 2 times 5 is 10, and then 5 minus 4 is 1, so that's an e to the 10. Okay, at that point, only one of my numbers came out positive. That one has to be the biggest. So what is the absolute max? Okay, so since I wrote too big, I'm going to just put it here. Absolute max is e to the 10. It occurs at x equals 5. Then what would I say for my absolute min? Well, I had 2 negatives. So you have two choices. You could type this into the calculator and see what it comes out to be. But you should be able to figure out which of these is smaller just based on estimating. What whole number is E pretty close to? 2. It's like 2 point something, right? So if I do 2 to the 7, let's count. 2 times 2 is 4, times 2 is 8, times 2 is 16. One more. 32. One more. One more. So 2 to the 7 is about 128. So if I were to divide that by 2 and turn it negative, this is about negative 64. So which of those is smaller? The 3.5y value. Very good. Now, don't put that in your table. That's what you're doing in your head. If you put negative 64, those aren't really the same. So I would say the absolute min is negative E7 over 2. It occurs at x equals 3.5. And that would be your answer. Okay? Yes?
So if you're doing absolute extreme, then you plug the numbers into the original.
Yes.
If you're doing the relative or local.
That's when you have to do a sign chart and look for plus minus or minus
put
plus.
Those numbers like the most simplified version, right?
Yes, correct. Okay, any questions on that? That's due tomorrow. It should have really been due today. If it's done today, go ahead and turn it in on your way out. But if it's not, okay, I'll be here after school today since I wasn't really here the last 2 days to help. You can come after school. Okay, homework 2, let's see what we learned yesterday. Sure. We're going to do number 5. Okay, so take a look at your homework 2. You should have gotten this yesterday. How do you do a second derivative test? What do you do first? First derivative, then second derivative. So what am I going to need to do the derivative of something with a fraction in it? Okay, you could do the quotient rule or you could just do a rewrite, which would be way easier. So I'm going to rewrite here. This is going to be RW x plus 1x to the negative 1. Now notice, the reason I'm doing that is to avoid having to do quotient rule. Quotient rule takes forever, okay, and if I can avoid it, I want to do it. So, what is the first derivative? This is f. So f prime would be what?
1 plus negative x to the negative 2.
Okay, so derivative of x is 1. Negative 1 times x is a negative 1, and then x is to the negative 2. Everybody agree? Okay, if I needed to do a sign chart, I'd rewrite it and get a common denominator. But I'm going to the second derivative test. So, second derivative, I'm just going to take it one more time. What's the derivative of 1? 0. It's a constant. Negative 2 times negative 1 is positive 2, x to the negative 3. And then from there, I'm going to rewrite that as 2 over x to the 3. So that's a really simple looking second derivative. What is my only critical number, even though it's not really called that? 0. Now, does 0 make that derivative 0 or undefined if x is on the bottom? Okay, that makes it undefined, but remember, that's still a type of critical number. F prime can be 0 or undefined. Now, from your notes yesterday, what's it called? So if it has a sign change, it's the point of inflection, but if you're not sure, what do you call it? KPPOI is a possible point of inflection. That means this is who I'm going to check, but it might not have a sign change. So set up your number line. My PPOI is 0. Pick a number bigger than 0. Maybe I pick 1. We're plugging in right here. What is 2 divided by 1 cubed? Positive. Positive 2. Okay, now pick a negative, maybe negative 1. Negative 1, if I cube it, how does it come out? Divide it with 2? Negative. Now, on the first derivative test, you label the bottom f prime. What do I label it for second derivative test?
F with a 2 double prime.
Okay, f double prime. And regular f, okay, I know increasing and decreasing from a first derivative test. What do I know for a second? Concavity. If it's negative,
Frown.
down like a frown, and then up is up like a cup. Okay? So the question says, during the interval, where is f concave up and concave down? So I'm going to abbreviate CCU for concave up. Where is it concave up? What interval?
Negative infinity to 0.
So for up, it would be 0 till infinity. That's okay. Yeah, I love your participation. Okay, and then what would I say for concave down? Very good.
X is greater than.
You could do that, sure. Yeah. So you do negative infinity to 0 because f double prime less than 0. Now, what she said, if you like, that's called inequality form, x less than 0, x greater than 0. Totally fine. AP test will use both. Got it? Wow, look at you.
I was running around on my phone, so.
You what?
During 2 of my classes, I was running around on my phone, so I just did that.
Might as well. Might as well be productive, you know? Oh, and you'll notice, Nikki, that on number 1, that's how the answer choices are, is in inequality form. Okay, you got it?
Yeah, but, okay, for number 1, I got all ups.
Huh?
I got all concave up.
No.
I know.
I didn't know.
I don't know where I looked.
Okay, come on, you guys. Number 1, what do you do for concave down? What are my steps? Let's just do it. Derivative how many times?
Twice.
Twice. So, y prime is going to be what?
12x cubed minus 48x squared plus 48x.
And then what about the plus 48 at the end? Gone. Okay, second derivative. Now, at this point, I don't like big numbers. I'm going to factor 12 out because I don't want to have to deal with the 12 in there. So I'm going to rewrite this as 12. Now it's an x cubed minus a 4x squared. Actually, I can take out an x too. Don't do that, though. Okay, and then plus 4x. Everybody good with that? So I'm taking out the constant because it'll be easier for me to take the derivative of the inside. So y double prime, my 12 is still in the front. What's the derivative of x cubed?
3x squared minus 8x plus 4.
Now, if you did not remove the 12, you would have to take the 12 out at this step anyway. So you might as well just take it out now, but you don't have to if you don't want to. Okay, then we need to factor that. So I would have 0 equals 12 in the front. I need a 3x and an x to get a 3x squared. And then I could put a minus 2 and a minus 2.
Yes.
So that'd be 6x minus, okay, good?
Yeah.
Yeah, okay. So from there, what are my two PPOIs?
2 and 2/3.
PPOIs are 2/3 and 2. Set up your number line. 2/3 is smaller, I'll put it here. 2 is here. What is a number bigger than 2 that I could choose? 3. So 3 minus 2 is positive. 3 times 3 is 9, and 9 minus 2 is also positive. Multiply 2 positives, get a positive. Between 2/3 and 2, maybe I pick 1. 1 minus 2 is
I was putting in
negative.
the first one.
Oh no, you got to plug into the second one. And then 3 times 1 is 3, minus 2 is positive.
Put in
So,
the original.
oh yeah, don't do that.
So we did every single one of these.
So if I plug in 1, I get a positive on the first parentheses, but I get a negative on the second one. Hello?
Plug it in the original.
Yes?
What we just did. For the,
I do have Brooke.
the chart.
Okay.
Yeah, I figured
Thanks.
or loop. It was relative.
You're free, Brooke.
Yeah.
You're getting picked up. Okay, so you know where you're plugging in now? Okay, so when I plug in here, I get 3 times 1 minus 2, and then I have 1 minus 2. So the first one comes out to be positive, the second one is negative, overall
Why don't we
negative.
put that in the original?
Okay, so listen, this is where you have to remember, if you're doing a line chart, you're plugging into the factored form, checking for a positive and a negative. If you are doing an absolute, that's when you go back to the original and see the original y values. Okay? Alright, then less than 2/3, maybe I pick 0. 0 minus 2 is negative. 0 minus 2 is negative. Multiply two negatives, get a positive. So
you have like a 2 and it's the x minus 2. What would you do?
okay, say that again.
So like I have a well, never mind. I was
Okay.
gonna say like what if there's a 2 that you had to plug in? Like what if it was like 8?
Well, so if it was 2, it would be a critical number, and you're not allowed to pick those. You have to pick a number to the side of.
Well, what if it was like 2/3 and 1, and you picked 2, and it was like x minus 2, which was like 2 minus 2?
That won't happen.
Okay.
Because if that would happen, it would have come up as one of your zeros.
Okay.
Okay, from there, remember that f double prime tells me, okay, focus, the concavity of f. So when f double prime is positive, f is concave up, concave down, concave up. Now the question is asking you what interval it's concave down for, so where would I be looking? 2/3 to 2, which is which answer? E. Good job. Okay? Well, not all of it, just the plugging in part. Yeah. Yes. Well, okay, so points of inflection are the same as mins and maxes. Because critical numbers might not have a sign change. Okay. Okay, so remember, homework 2 is not due till Friday, so if you still have questions, you can ask. Okay, ready for your notes for today? Whoop. Here we go. Okay, so concavity. Let's talk about what concavity is besides just knowing what the picture is. Concavity, we're going to put it up here at the top. Concavity is F double prime, yeah? Okay, ready? Concavity is F double prime, which means that it is the slope of the slope. Okay, so think about that, what that means for a second. F double prime is the derivative of the derivative. So it's the slope of the slope. So what concavity tells you is whether the slope is increasing or decreasing. So when F double prime is positive, the slope is increasing. When F double prime is negative, the slope is decreasing. So we're going to draw 4 little pictures. We're going to break it down into combinations and look at each one. The first 2 that we're going to do are going to be this one and this one. The second 2 that we're going to do are going to be this one and then this one. Oh wait, crap, don't draw that. There. I have to get it white out. Sounds like it's from Black Panther. T'Challa. That's what it reminds me of. Okay, ready? Okay. So, top left, look at just this picture once you've drawn all 4. Okay, this one. Is F increasing or is it decreasing? Okay, so I'm going to put F is increasing. What does that tell me about F prime? It's positive. Okay, when F is increasing, F prime is positive. Now, let's look at a second characteristic now we also know about concavity. So, look at the graph. F is increasing, and what's its concavity? Concave up. What does that tell me about F? That F double prime is positive. So far, so good? So if it's increasing, F prime is positive. If it's concave up, F double prime is also positive. Look at the second graph. Okay, it says we have F prime, positive or negative for this graph? Positive, because what is F doing? Okay, f is increasing. That tells me f prime of x is positive. But what is f double prime? It's concave down. That means f double prime must be negative. So f is concave down. So f double prime of x is negative.
Why is it like concave up?
Okay, so look, this is like part of a smiley face. This is like part of a frowny face. Like up like a cup or down like a frown, yep. Okay, good. Now, the sentence I want you to add to that you should have been able to do yesterday. Okay, the sentence I want you to add to that is that for this graph, what is the slope doing if the second derivative is positive? The slope is increasing. Now, look at your graph. Does it appear that the slope is increasing?
Yes.
What's happening to it is getting steeper. So I'm going to put f is increasing at an increasing rate. Versus for the second graph, what am I going to put? It's increasing, but at a decreasing rate. So listen, hold on, we'll draw it in a second. Okay, so this is what I mean by increasing at a decreasing rate. My y values are still increasing, but as they increase, the slope is flattening out. So this graph is getting steeper because the slope is increasing. This graph is getting flatter because the slope is decreasing. So the first word that you're saying here is a result of f prime. The second result is from the sign of f double prime. The first derivative tells me it's increasing. The second derivative tells me how it's increasing. If it's increasing faster and faster and faster, or slower and slower and slower. Good? Okay, look at the next two graphs. First one, it says f is increasing or decreasing for graph number 3. Okay, f is decreasing. What does that tell us about f or f prime? Which one? F prime. F prime of x needs to be negative. What is the concavity of the third graph? Concave down like a frown. And if it's concave down, that means f double prime of x is also negative. Okay, now, here's where this can get really tricky, because a lot of times you guys think, oh, it's steeper, it's going faster. Okay, look at my finale statement, if you will. So I would say f is decreasing at a decreasing rate. Okay, write it down. F is decreasing at a decreasing rate. Now, I want you to think about what that meant in your head last time. Decreasing at a decreasing rate last time, we were thinking, oh, that makes it flatter, it's slowing down. Is that the case for this graph? Is it getting flatter? No, it's getting steeper. So, there is a difference between steeper and flatter and this statement right here. Here's why. I'm going to do my best to explain it on this graph, then I'm going to explain it one more time here. I want you to draw in the slopes on the graph. So here, what could my slope be at the top if it's flat? 0. Okay, scooch over, so we'll put a 0 there. I know it's in yellow, but just do your best. Okay, then scoot over a little. What's the slope maybe here? Maybe negative 1. Okay, then I scooch over a little bit more. What's the slope there? Maybe negative 2. Then I scooch over a little bit more. What's the next slope? Negative 3. Next one. Negative 4. Okay, now question. If I were to put all those slopes in a line, 0, -1, -2, -3, -4. Are those increasing or decreasing? Decreasing. Does that mean it's not getting steeper? No. Those are different questions. So here's the difference between steepness and this. Steepness is going to happen when your signs are the same. Look at your two graphs that both got steeper. Here they were both positive, F prime and F double prime. That made the graph go steeper. Here both of them were negative, decreasing and decreasing. That made my graph get steeper. So that is not the same as what I'm saying here. So I'm going to put steeper happens when F prime and F double prime have the same sign. Now, obviously you could say from there, well then flatter happens when they're opposite signs. Okay, but one more time, what this means is that each of my slopes as I go down the curve is getting smaller. But for negatives, that means steeper. Because -1 to -2 is a change in a steeper direction. -3, steeper than that. -4, steeper than that, but it's still decreasing in value. Okay, look at the next graph. Increasing or decreasing? Okay, F is decreasing. What does that tell me about F prime? Okay, it's negative. What do we know about the concavity? Okay, it's concave up. What does that tell us about the second derivative? It's positive. Okay, but when I write my kind of finale statement, I would say F is decreasing, but at what kind of rate? An increasing rate, and that is backwards to what a lot of you would maybe think. So F is decreasing at an increasing rate. Okay, now I'm going to do the same slope explanation that I did on the other one, and hopefully it'll kind of make sense. If I'm way over here on the side, maybe the slope is negative, we'll say 4. Scooch in a little bit. What's the slope here? Maybe -3. Scooch in a little bit more. Maybe it's -2. Scooch in a little bit more. Maybe it's -1. What is happening as I go from -4 to -3 to -2 to -1? Increasing or decreasing? Increasing. So as my values become bigger from the negatives, that's actually flattening out your graph. Okay, and remember, the reason that that happens is because they're opposite signs. Okay, my graph is flattening because they're opposite signs. Okay? Alright, so take a look at number 1. This is off of the AP test a couple years ago. It says for all x on the interval 2 to 5, I have a negative first derivative, and I have a positive second derivative. Which of the following could be a table of values for f? Okay, so let's think about what those two things need. So Chris, if my first derivative is negative, what does that tell me about my function? Decreasing, perfect. Okay, so look at your graphs, everybody. Cross out one of them is not decreasing, which means it's not a match. Which graph is not decreasing? D. That graph is increasing because my values go 7, 9, 12, 15. That's increasing. I want decreasing, not going to work. Okay, the second statement is that my second derivative has to be positive. What does that tell me about my graph? Concave up. So draw for me a little picture of a graph that is decreasing and concave up. Decreasing, concave up. And then I want you to write on your paper if it's getting steeper or flatter. Decreasing, concave up. Okay, you should have drawn that. Steeper or flatter? Flatter. So, my slope is getting flatter as I go across. So look at A. What is my slope each time? 15 to 13, it went down 2. 13 to 11, it went down 2. 11 to 9, it went down 2. That is a constant slope. Is it getting steeper or flatter? No, that's not what I want. Look at the next one. 15 to 14, how many did it go down? 14 to 12? 2. 12 to 9, how many? 3. Your jumps are getting bigger each time. Is that steeper or flatter? That's steeper. What do I want? Flatter. So it has to be C. Look at your Y values. 15 to 12, minus 3. 12 to 10, only minus 2. 10 to 9, only minus 1. That is getting flatter. So that is my match. Make sense?
Yes, ma'am.
Okay, what I want you to do is, on the back of homework 2, there's one, the very last question is just like that. So while you're thinking about it and it's already in your head, okay, I'm going to give you a minute to look at 13 off homework 2. Okay, you have a positive first derivative this time and a negative second derivative.
Nice.
Did you already find it? Yep. Good job. Okay, I want a positive first derivative. F prime has to be positive. What does that tell me about F? Increasing or decreasing? Increasing. Which graphs can I eliminate because they are not increasing? C, D, E. They're all what? Okay, those are all decreasing. So I have 3 easy eliminates. Okay, out of the 2 that are left, I need my concavity to be negative. Should it be getting steeper or flatter if one is positive and the other is negative? Flatter. So look at your jumps. 7 to 9 is a jump of 2 increasing. Next one is a jump of 3. Next one is a jump of 4. Is that getting steeper or flatter? That's getting steeper. Is that what I want? Steeper would have meant they're the same sign. Okay, but flatter is when they're opposite. So 7 to 11 is plus 4, then plus 3, then plus 2. Those are getting flatter. So those are the guys that we want. We want B. Make sense?
Yes, ma'am.
Easy?
Yes, ma'am.
Okay, flip over to the back side of your homework. Or of your notes, my bad. Okay, so the other thing that they test a lot on the free response, so every year there are 6 free responses. Every year there's one table like this. These are your free, easy, you should never miss these question points. Okay, so they're a little confusing the first time, but then they should be like a cinch after that. So look at the top, you have a table. You have values of F, F prime, and F double prime. Okay, question A says identify critical numbers. Okay, critical numbers are when F prime equals what 2 things?
0 and undefined.
Okay, good. So look in the F prime row, and I want you to write down when F prime of X is 0 or undefined. There are 2 places that I see. Okay, when F prime is 0, and when it's D and E, what are my X values? 2 and 4. X equals 2, X equals 4. Now look what it says. Identify each as a relative min, max, or neither. Well, then I need to do a sign chart. So set up your sign chart. 2 and 4 are my critical numbers. To the left of 2, what is my sign for F prime? It was 4, which is positive. Now remember, that's my test point. So instead of me having to plug it in, they're just telling me it would have come out to 4. Now, between those 2, what was the sign? My test point is 3, and I got a negative 1. To the right of 4, say my test point is 5 or 6, what would my value have come out to be? Positive. So remember, if those are the signs for f prime, that tells me that f changes from increasing, decreasing, increasing. And that helps me figure out whether each of those is a min or a max. At 2, what is it? Okay, we'll say a relative or a local max. Does it say to justify? Yes, it does. So I'm going to put because f prime of x changes positive to negative. Okay, and that's your justify piece. So you're telling me it's a max because f prime changes from plus to minus. Now, what about 4? What do we say 4 is? A relative min because f prime changes negative to positive. Okay, and there's your justification down there at the bottom. Now, if it did not say to justify, then you would not have to. But since it does, we got to do it. Okay, now, next thing it asks me to find are my points of inflection. How do I find my possible points of inflection? What derivative should I be looking at in the chart? F double prime. Where is F double prime? 0 or undefined? At 3 and where else? Yeah, 6. Good. So 3 and 6 are my PPOIs. PPOI. 3 and 6. Set up your line chart. To the left of 3 in the F prime row, what are the signs to the side over here? They're both negative. Between 3 and 6, what are the signs of F double prime? 3 and 4 are both positive. Now, on the other side of 6, that's an endpoint. I'm just going to put a question mark. We don't know what happens out there. So, which can I classify as a POI? Only x equals 3. Oops, I wrote that in the wrong part. Do you notice that? It should have been here. Oops. Okay, x equals 3, POI, because f double prime of x changes sign. Do I have to say from negative to positive? No, concave down, concave up, f double prime f. Okay, and then make sure you do want to label your little line chart. Okay, the last thing that we're going to get to right now is just the little sketch in part B. So parts D and E we're going to do tomorrow, so please don't throw this away. But the first thing we're going to do, so these are totally backwards for mine because I messed up. Okay, is it says in part C to draw a graph with the characteristics. So the easiest place to start for these is to just sketch the y values because those are going to be really easy. So what is my first point that I'm given here? 1, 3. At 1, f of x is 3. So 1, 1, 2, 3, put a point. At 2, what's f of x? 5. So 2, 3, right there. Goes up. Okay, then 3, 3. That would be even to the one I had already placed. 4, 2. I should be 1 below. 5, 4. I should be up here. And then 6, I should be back down to 3. All that you have to do is indicate whether it's increasing or decreasing and whether it's concave up or concave down. So I'm going to go one little chunk of the graph at a time. From the beginning until 2, what is my graph doing? Increasing. How is it increasing? Concave down or concave up? Look at your second derivative test, concave down. So when I connect these dots, I have to go like that. Because it's increasing and it's concave down. Now, from 2, what does my graph start doing? Decreasing, but how is it at 2 still? Concave down. So my next chunk of the graph is decreasing, concave down until 3. Now, at 3, what happens? I'm still decreasing, but I'm what after 3? Concave up. So I'm going to keep decreasing, but I'm going to switch to being concave up. Okay, then look at what happens after that at 4. So that's where I'm at right here. This is 4. My graph switches to increase, but what's the concavity still? Up. So I'm switching to up. Still concave up. Okay, and then after that, between those last 2 points, I'm still increasing, but why is my point down there? Yeah, that doesn't really make sense. So just pretend he's not there.
Yay.
Well, there's no way I can increase to a point that's underneath it, so I made this table, I think. Oops. Okay, you get the idea, though? Now, sketching is not on the AP test a lot, but the A and B questions are on there a ton. Okay, you can do it. Good job.